Hello students, most welcome in the another video of the chapter Structure of Atom. I am sure students, you have done your previous work. Many topics of this chapter we have covered. So let's start the today's topic of the chapter Structure of Atom. Now students, most important topic of the chapter is shapes of the atomic orbital. My dear students, everybody knows what is orbitals. Orbitals is the three-dimensional space around the nucleus where probability of finding the electron is maximum. And previous day we have discussed about these orbitals. Now, shapes of the atomic orbital, today's topic. Students, for 1s orbital, the probability density is maximum at the nucleus and it decreases sharply as we move away from. What I am telling? For 1s orbital, the probability density is maximum at the nucleus and it decreases sharply as we move away from it. Now let's go for 2s orbital. For a 2s orbital, the probability density first decreases sharply to 0 and then again starts increases. So what's about the 2s orbital, my dear children? For a 2s orbital, the probability first decreases and then it increases. After reaching a small maxima, it decreases again and approaches 0 as the value of r increases further. So different things are happening for the 2s orbital. First one, that is it decreases sharply to 0. Second, it's again start to increase. Third, when it will increase, it will reach a small maximum. It decreases again. So first decreases, second increases, third it decreases again, and then it approaches 0 as the value of r increases further. So this is important for 2s orbital. Now students, let's go. What's the others orbital? The region where this probability of finding an electron reduces to 0 is called nodal surface or simply nodes. What is nodal surface? What is nodal surface? The region where this probability of finding an electron reduces to 0 is called nodal surface or simply nodes. This question is important in the exam. So what is nodal surface? The surface where the probability of finding an electron reduces to 0 is called the nodal surface or simply nodes. My dear children, you note down this question in your notebook because frequently this question is coming in the exam. What is nodal surface or simply nodes? Next, in general, for an ns orbital has n minus 1 nodes. That is, number of nodes increases with the increase of quantum number n. Therefore, for 2s, it will be 1. 2 minus 1, that is 1. For 3s, it will be 2. Next, boundary surface diagram of constant probability density for different orbitals give a fairly good representation of the shapes of the orbital. In this representation, my dear children, a boundary surface or a counter surface is drawn in space for an orbital on which the value of probability density is constant. So, in the exam, the second type questions, we have to calculate how many nodal planes or nodes are present for 2s orbital, 3s orbitals, and what is the formula for calculating the nodal planes. You have to know that is n minus 1 nodes. So number of nodes you have to calculate for different type of orbitals, 1s, 2s, 3s, etc. So second questions you write how many nodes are present in the 2s orbital, how many nodes are present in the 3s orbital. You note down in the notebook, my dear children. In the boundary diagram, surface diagram, the nucleus is taken to be at the origin, or rather it is showing the boundary surface diagram, which is the origin. Nucleus is taken at the origin. Okay. Now, here diagram are not spherical like the s orbital. Here the p orbital consists of two sections that are on either sides of the plane where the two lobes touch each other. The size, shape and energy of the three orbitals are identical. Since the lobes are considered along the x, y and the z axis, they are designated as the above 2px, 2py and 2pz. It should be understood that there is no relation between first magnetic quantum number and x, y, z direction. So this is very important thing, students. You have to learn that 2px, 2py and 2pz. It should be understood that there is no relation between first magnetic quantum number and x, y, z direction. The lobes are considered along the x, y and z axis. They are designated as 2px, 2py and 2pz. Just to see boundary surface diagrams for p orbital, 2p orbitals, 2px, 2py and 2pz. So students, just boundary surface of diagrams for 2p orbitals along the x direction, that is 2px, along y direction 2py and along the z direction, that is 2pz. So this is the boundary surface diagram for 2p orbitals. You note down, you draw the diagram in the notebook. So what is node and the calculation of the nodes for different type orbitals, diagram of the different type orbitals, that students you have to practice more and more. Next students, d orbital. The 5 d orbitals are designated as dyz, dxz, dx square y square and dz square. Another students, here we have to write, here only 4 d orbitals are given. Another d orbitals dxy, dyz and dzx. One is missing here, that is dxy. So students, you note down in the notebook 5 d orbitals. 4 d orbitals are given here. 1 d orbitals you have to write, that is dxy. So you write quickly students, dxy, dyz, dxz, dx square y square and the dz square. The shapes of the first 4 d orbitals are similar to each other, whereas the fifth one is different from others, but all 5 3d orbitals are equivalent in energy. The d orbitals for which n is greater than 3 also have shapes similar to 3d orbital but differ in energy. When two nodal planes pass through the same origin and bisecting the xy plane and z plane, these nodes are called angular nodes. So what is angular nodes, my dear children? When two nodal planes pass through the same origin and bisecting the xy plane and z plane, these nodes are called angular nodes. So from this one question I'm asking you, how many d orbitals present in d subshell? Yes students, your answer is absolutely correct. 5 d orbitals. Name the 5 d orbitals, students. Okay, you are also absolutely correct. dxy, dyz, dxz, dx square y square and dz square. Angular nodes are denoted by L. There are 1 angular nodes for the p orbital and 2 angular nodes for the d orbital. The total number of nodes are given by n minus 1. That is, the sum of L angular nodes are n minus L minus 1 radial nodes. So total number of nodes are given by n minus 1. That is the sum of L angular nodes are n minus L minus 1 radial nodes. Now students, the total number of nodes for an orbitals are given by the expression n minus 1. Total number of nodes are given by n minus 1. That is the sum of the angular nodes L and the radial nodes n minus L minus 1. So again I am telling, note down in the copy, the total number of nodes are given by n minus 1. If I tell you what is the number of nodes for the 2s orbital, answer is 2 minus 1, that is 1. For 3s orbital, that is 2. So number of nodes for 2s orbital is 1 and number of nodes for 3s orbital is 2. But the total number of nodes is the sum of the angular nodes L and the radial nodes n minus L minus 1. So, questions will come in the exam. Calculate the number of nodes for the 2s orbital. Total number of nodes. So, 2s orbital, it means that n equal to 2 and L equal to 0. So 2 minus 0 minus 1, that is 1. So total number of nodes. First you calculate the principal quantum number value of the orbital. Second, azimuthal quantum number value of the orbital and calculate n minus L minus 1. N minus L minus 1 radial nodes and angular nodes is L. So total number of nodes is n minus 1. So n minus L minus 1 plus L. So minus L plus L will be cancelled. So total number nodes will be n minus 1. So for 2s orbital it is 1. For 3s orbital it is 2. For 4s orbital it is 3. So this is the total number of nodes. So students, one question I am asking you, tell me the answer. How many nodes of the orbital? Yes, you are absolutely correct. Two types nodes. One is the radial nodes, formula is n minus L minus 1, and another is the angular nodes, that is L. L means azimuthal quantum number. Student, second question. What is the formula of the total number of nodes? Yes, it is sum of the angular nodes and the radial nodes, that is n minus 1. Now students, I am going to describe the energy of the orbitals. And students, we have to study the very important topic in this chapter, electronic configuration of the elements. And for this, you have to know the energy of the orbitals. Energy increasing order in the orbital is given as follows: 1s, 2s, 2p, 3s, 3p, 3d, 4s. As 2p and 2s orbitals are different, an electron has the same energy as it is present in the 2p or the 2s orbital. The orbitals which have the same energy are called the degenerate orbital. So students, what is degenerate orbital? Answer is the orbitals having the same energy. The 1s orbital in a hydrogen atom corresponds to the most stable condition and is called the ground state. And an electron residing in this orbital is strongly held by the nucleus. So what is ground state? 1s orbital. Okay. The electrons residing in the 2s, 2p or higher orbitals in the hydrogen atom are said to be in the excited state. The attractive interactions of an electron increases with the increase of the positive charge on the nucleus. The attractive interactions of an electron increases with the increase of the positive charge on the nucleus. So, when the nuclear charge will be increased, attraction between the nucleus and the valence electrons will be increased, my dear students. Now, due to the presence of electrons in the inner cells, the electrons in the outer cells will not experience full positive charge of the nucleus. When the inner cell more, then the attraction between the nucleus and the valence electrons will be decreased. The effect will be lowered due to partial screening of positive charge on the nucleus by the inner cell electrons, and this is known as the shielding of outer electrons from the nucleus by the inner cell electrons. And students, you know that in the periodic table you have learned the size of the element will be decreased from left to right due to the increased nuclear charge and the decreased shielding effect. The net positive charge experienced by the outer electrons is known as the effective nuclear charge, that is Z effective. In other words, the energy of interaction between the nucleus and the electron decreases with increase of atomic number. This is very important, students. Already I discussed why the size of the element in the periodic table from left to right, that is decreases, and from top to bottom the size of the element increase, that we have already discussed. So what is shielding effect, students? The effect will be lowered due to partial screening of the positive charge on the nucleus by the inner cell electrons. Now, very important principles I am telling you, students. And if you don't know these principles, you can't complete the electronic configuration of the elements. According to these principles, in the ground state of the atoms, the orbitals are filled in the order of the increasing energies. That is, the orbitals having the least energy will be filled up first. Then the orbitals will be filled up according to their increasing order of the energy. Order of increasing order of energies in the orbital: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 4f, 5d, 6p, and 7s. Students, before going to other things, I am telling one important thing here. Just to observe here. 1s orbital energy is less than 2s, 2s less than 2p, 2p less than 3s, 3s less than 3p. After that, 4s. It may be 3s, 3p, 3d, but students, 4s energy is less than 3d orbital. That's why 4s orbital will be filled up first, after that 3d orbital. Do you know what is the reason behind this? Yes, students, who told the answer? The answer is very much 100% correct answer. N plus L rule. N plus L rule. There is one rule, that is, if N plus L is lower, then its energy is lower. If we compare the N plus L value of 4s, N equal to 4 and L equal to 0. So N plus L for 4s orbital is 4. But next we go to 3d orbital. For 3d orbital, N plus L value, N equal to 3 and L equal to 2 for d orbital. So what is the value of N plus L for 3d orbital, students? 5. 3 plus 2, 5. So 5 is greater than 4. So which orbital has less N plus L value? 4s orbital. Which orbital has less energy? 4s orbital. So what is the rule? When N plus L value is less, energy is less. That's why 4s orbital is filled up first and then 3d orbital. And this is Auger principle. Order of filling up of electrons: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So this is the order that you have to follow when you distribute the electrons in the atoms or ions. Second principle is Pauli's exclusion principle. According to this principle, students, no two electrons in this atom have the same set of 4 quantum numbers. Students, my dear children, if two electrons have the 3 quantum numbers equal, that is n, l, m value equal for 2 electrons, then the 4th quantum number, that is spin quantum number, will be different. If spin quantum number for one electron is plus half, then it will be minus half for other electrons. And this is Pauli's exclusion principle. The maximum number of electrons which can be accommodated in the cell with the quantum number n is according to the 2n square rule. So if I tell you how many electrons can accommodate in the third cell, so 2 into 3 squared, that is 2 into 9. that L18. So in this formula, we can calculate the number of electrons for any cell or orbit. And next rule is the Hund's rule of maximum multiplicity. This rule deals filling of electrons in the orbitals belonging to the same subcell of equal energy. Suppose if you have 4 electrons in the p orbital, 2p4, suppose, how many electrons will be distributed in the px, py and pz? Px, py, pz have equal energy. So according to the Hund's rule, the pairing of electrons will be started in the orbital having same energy after filling each orbital by 1 electron. Suppose if we have the 2p4, that is there are 4 electrons in p orbital, how will distribute in the p orbital? First, according to Hund's rule, px1, py1 and pz1 and extra 1 electrons, then pairing will be started in the px orbital, that is px2, py1 and pz1. This will be the electronic configurations of the different orbitals of the p subcell according to Hund's rule. So electronic configuration rule I am telling, the distribution of electrons into orbitals of an atom is called its electronic configuration. Electronic configuration can be represented in two ways, normal notation and orbital diagram as given in the textbook. The electrons in the completely filled electronic cell with the highest principal quantum number are called valence electrons. So valence electrons means the electrons which is present in the valence cell, that is outermost cell, is known as the valence electron. And students, electronic configuration means distribution of electrons into orbitals is known as the electronic configuration. And students will practice many atomic electronic configurations, ion electron configurations, and we'll discuss the exceptional case in electronic configurations for the chromium and the copper. Chromium atomic number 24 electronic configuration argon 3d5 4s1 and copper electronic configuration argon 3d10 4s1. Actually, the general process, general rules, chromium, argon 3d4 4s2. But you know I have discussed in the class that half-filled orbital and full-filled orbitals are more stable orbital due to their symmetrical distribution of electrons and the exchange of energies there. Two factors related for the stability of the half-filled and the full-filled orbital, my dear students. So there is the exceptional case in the configuration of chromium and copper. So I am telling you, students, I am asking the two questions here. What is the electronic configuration of chromium, my dear children? Anyone, can you tell me? Yes, you are absolutely correct. Chromium is argon 3d5 4s1. Now second questions. Can you tell me, students, what is the electronic configurations of copper? Yes, you are 100% correct. Argon 3d10 4s1. d5 and d orbitals, d10 orbitals are completely filled. d5 is half filled and d10 is completely filled, and half filled and full filled orbitals are stable due to their symmetrical arrangement of the electrons and more exchange of energies. Okay, students, so this chapter is finished and I hope you understood very clearly these chapters, and I am giving few assigned work on the electronic configurations of the elements that you have to do, students. So thank you and be safe, stay home and do your task. Okay, next day we'll come with the question answer of the chapter structure of atom.